And now, from the CFTK-TV studios, this is Open Connection with your host, Robert Pictou.
Welcome to Open Connection. I'm your host, Robert Pictou. In May 2021, the Government of Canada launched the Canadian Greener Homes Initiative to help Canadians make energy-efficient upgrades to their homes, fight climate change, and create good jobs, all the while helping homeowners save on their monthly energy bills. Today in Open Connection, we bring you a special two-part program featuring Certified Energy Advisor Nick Gascon.
Well, I grew up in all parts of Canada, mostly was Terrace, BC. My family is Canadian Tire family. Everyone knows my dad, Brian. We moved across from Alberta, Saskatchewan, Ontario to BC. We ended up in BC in Terrace in 2000. And we thought this was going to be a 3-year plan and we would be moving again. And then we just started to learn to love the land and we stayed. My whole life growing up, I planned on Canadian Tire. So I thought about it for many years and grew up, and since I was a little kid, I was working in the store. And at one point I decided this isn't for me. So I decided, what am I going to do? So I had to try new industries, and I fumbled around a little bit trying to find what I wanted, and I ended up realizing construction is where I wanted to be. But I didn't have 10 years of experience swinging a hammer, even though I did understand it quite a bit. I found a better place for me in the world of the computer world and in design. So after Canadian Tire, I ended up finding some room in the offices in construction world as well as in design of trusses. And that's where things really started to focus in on what I wanted to do. So I started as a truss designer. I was learning taking a two-dimensional floor plan and creating it into a three-dimensional model, and that gave us things like the load dimensions, the trusses, the joists, the beams, the engineering for them. And if the home wasn't going to engineer properly, we had to strengthen the home in ways, strengthen the beams, the trusses, etc. And that opened up a world of understanding the building envelope and the way a home is built. And I was encouraged into the world of energy advising because of the lack of energy advisors in the Northwest. An energy advisor is an advisor directly for the client, and they help homeowners make wise decisions on improving their home. So if someone says, my home is drafty, I need to find out why I'm losing so much heat. An energy advisor would go in and assess the entire home, anything from the building envelope, so the walls, the ceiling, the basement foundation, the windows and doors, and they'll verify this entire house, how it operates, and it will create a consumption report. And this helps a homeowner feel more informed, and it gives them an idea of where they're losing their heat and what sort of systems in their home are using up too much energy. Yeah, so the average home here is a 60s home. People call it the BC box term. You see the rectangular homes. They all look very similar with small additions to aesthetically. These homes are needing a lot of work. They're using older furnaces. In some cases they have poorly insulated homes, older windows, and insulation in the attics that could be a lot more. You can look it up on the Enercan website. Google how to become an energy advisor. And you have to do 2 formats of training. There's the foundation exam and the energy advisor exam, and both of which you need support from a service organization. So to go out on your own isn't quite going to work because you're going to need someone that's well versed in the industry that can help manage all the files that you're going to bring in data. So there's companies like Gets Energy that are in the area. There's companies in Calgary as well and in Ontario as well that all across Canada they can support. But in particular, my service organization is Gets Energy. So they are based out of Victoria. So they would help me with the training to become an energy advisor, and they support with any sort of additional experience in the field, help with your probationary files, and just help you through all the challenges that come with it. Because when I first started, I couldn't find all the right information. So they made it a lot easier for me. So the course is based on all of Canada training, right? So you're focusing on doing your certification through NRCan, so Natural Resources Canada. So the tests are done in two sections. So the foundation is just talking about how the house is performing. So you learn the house as a system, you learn how everything operates and how one thing can affect another in the performance. And this is all training that's already online, and the service organization can provide that training to make it easier for the advisor to learn. The second part of the test is the Energy Advisor certification, the exam. And this one focuses more in on what the tasks are for the Energy Advisor. So for instance, we use a program called Hot 2000. And this is a program that calculates the heat loads on the home and all different variations, including the correct weather climates for it. It helps take the pressure of the home in different pascals and creates the air leakage results. And this software is not something you can just pick up and learn. You need extensive training on it. So there's online training for that, and there's also in-field training to help support the knowledge base before you can take your exam.
Open Connection will be right back after these messages. And now, from the CFTK-TV studios, this is Open Connection with your host, Robert Pictou.
You've been thinking hard about the future and all the ways we can do our part, like improving the energy efficiency of your home and its resilience against climate change. But the journey ahead is long, and renovations can be stressful. And how can you really know whether your retrofits will have long-term benefits and savings for your home? That's where we come in. Participating in the Canada Greener Homes grant process guarantees home energy savings, while the Canada Greener Homes loan helps to make your efforts even more rewarding.
Thank you for staying with us. With buildings, including homes, accounting for 18% of Canada's greenhouse gas emissions, energy-efficient retrofits are an important component to Canada's commitment to reaching zero net emissions by 2050. Let us return to the conversation with Certified Energy Advisor Nick Gascon.
If you want to do it, you would just contact a service organization. And there's many throughout BC, but for instance with Gets Energy, I just gave them a call. And a funny story about that is when I was trying to find a service organization to answer them on the phone, which it was pretty challenging because they're very busy, I went and I looked through the list and I saw Gets Energy and I went, hey, I think I know that name. His name was Daniel Giam. And I used to know that name from Terrace way back when I was growing up. And I called him, I said, did you used to live in Terrace? And he said, yeah, how'd you know that? I said, well, we grew up together. So it made it a lot easier, and we already knew each other starting out this process, and he was able to give me all the correct training to help me get started and get going. Yes, they will help you get started, right? So they want you to feel comfortable going into a home, right? So the training is just to start, and then there's a probationary file training. So they will come to the home, to your town, and they will do a couple houses with you, make sure you feel you understand what's going on, and they will help you walk through your files. So the training on site with the home is about 1 to 2 hours, the Energuide assessment, and then the online software part is 3 to 4 hours. It sometimes can be shorter depending on the home. But when you first start out, it feels like 2 days. just learning all the different program functions. And you don't have to submit that directly to Natural Resources Canada and hope you did it right. You would submit that to your service organization, which helps critique it and make sure it has the right program functions and the quality is there. Quite a bit actually when I first started out, I had a few mistakes. And it took quite a bit until I understood how the program fully functioned, and now it's a no-brainer. I'm off and running. I know the person that first house I did is going to laugh. I can't speak too much about it due to client relations, but client privacy. But this home was a bit of a monster Frankenstein kind of house. It was built in the 60s, I believe, and it had multiple different wall assemblies. One of the walls was solid wood. For instance, there was no insulation in it. It looked like the house was built with multiple extensions, and it was. So I had to figure out what was the extension, where did it start, and what was the characteristics of that wall. So it was a nightmare. But it was fine. He was really great, and he was doing a complete restoration of the home. He was doing full basement renovations. He's doing the ceiling. He's doing windows, doors, new heat pump. A lot of air leakage was in it, so he did everything, and it ended up becoming very rewarding for him on the grant side. Sure, so our clients generally go to getsenergy.ca and they book an assessment there. Sometimes they call me first and I walk them through it as well. Our booking team will get all their information, start with their address, their name and contact details, and what they're trying to accomplish. From there, we book an assessment and I will arrive on site. I greet the homeowner, I let them know what I'm doing, and I start my process. So the process starts with me walking on the exterior of the house. I measure all the dimensions and find out where there would be exposed floors, if you had an exposed floor that's not over the basement, and verify what those components would be in order, from an R value, from an insulation standpoint. I go into the house and I start at the bottom. I look at the basement, I look at how much space there is in there from a ceiling standpoint, how much height. I'm basically trying to build a profile and volume of the house. I measure the mechanical systems, find out what is currently installed, look at things like their make and model and their consumption, and I work my way up and I find out how tall the joists are, the wall assemblies, the window characteristics, find out what type of window it is, double pane, triple pane, low E-coated, what type of spacer it is. And I go up to the ceiling and I will go inside the attic and measure what is the depth of that insulation, what kind of insulation is it. All this information gives me an idea of how to build a home in the software. After this is done, I go and do a pressure test using a blower-door system. This system sits in the door frame. It is a Retrotec 5000. What it does is it pressurizes the home to 50 pascals, creates a negative pressure. So by pushing air out of the house, it will force air through in all the cracks and air leakage points. And with a homeowner, I can walk around and I can identify exactly where those leaks are because it feels like a windy day pushing through those air leaks.
Open Connection will be right back after these messages. And now, from the CFTK-TV studios, this is Open Connection with your host, Robert Pictou.
Your journey begins by applying online, where you'll need to select a service organization near you. These companies have been certified by Natural Resources Canada to conduct EnerGuide evaluations. They'll connect you with an energy advisor to do a pre-retrofit EnerGuide evaluation of your home.
Welcome back to Open Connection. Making improvements to reduce the draftiness of your home is the single most important retrofit you can make to improve energy efficiency and should be considered the first of any retrofit strategy. Let us return to the conversation with Certified Energy Advisor Nick Gascon.
And I help give them tips on how you can improve that and by reducing the air leakage. This information from the blower-door test is measured in 8-point sets of data that is entered into the software. And based on the volume of the house that I built on the software, it can determine exactly how many air changes per hour that house is leaking. So a good home, a new construction home, is anywhere around 1 to 2 air changes per hour, which is at this 50 Pascal mark. A home and terrace is anywhere from 6 to 9 air changes currently right now. We're talking 60s to 90s homes are hitting around that range. Some better, some worse. In particular, that seems to be the biggest challenge that we're focusing on right here. Give you a case study. The home that I first did, the very first assessment, was about 10 to 12 air changes per hour, depending on which reading we chose. And that was very drafty. This home needed some serious work. We ended up bringing it from 12 air changes down to 2 air changes through finding the leakage with the blower-door system and also using a technology that takes a vapor caulking in the air and it will pressurize the home, positive pressure, and we spray this mist in the air and it will actually detect and leave all the leaks and cracks and it will seal up all those little holes. So incredible technology, and that was able to help them. Those are for extreme case scenarios when someone's doing a complete renovation to their home. They're taking out all the flooring, all the kitchen covers, everything, and this is one trick that they can do to identify all those leaks very quickly using just pressure to support your air leakage. The very first assessment that we do is our pre-assessment. So every home needs a baseline measurement, just like a baseline health for the home. How is it running today? And this test that we do gives you a baseline, and we submit this to Enercan. And they have it on file, and it's there for a long, long, long time, many years. And so whenever you do changes to your home, you can call us back and we'll reevaluate the home. How much did it improve? And that's our post-assessment. At that point, you have a post-assessment, there's been an improvement in the home. Let's say you've changed the heat pump out, you've put some new windows in, added more insulation in your attic, you've built a whole new basement insulated with an interior wall. And you can get your grants, you can apply for your grants with this post-assessment. So every person, it's a two-visit system with an energy advisor. And we help guide the homeowner through the application process. So it's not easy to do from a computer standpoint. There's a lot of hoops and jumps you can imagine to go through to apply. So we help support that and make sure they're doing the right thing and make it a lot more simple of a process. Yeah, so we're very notorious in the Northwest for having natural gas furnaces. And quite a few of them, because we just can't get to them all, are a mid-efficient furnace. So they're running at about 75 to 80% efficiencies, and they're just older and they just need to be serviced or replaced. So these furnaces are very high consumption rating, and replacing them with a newer high efficient natural gas furnace or to a heat pump or to a dual fuel system where you can use a combination of both are really great options that people are focusing on right now. Well, so this is an interesting topic. So we get that conversation about heat pumps and they go, well, I don't want a heat pump because if the electricity goes out, my heat pump's going to stop working. Okay, well, your heat pump operates on electricity, I get that. So does your furnace to get it started. So if your electricity goes out, your furnace is out. So everyone is concerned about that in the Northwest BC, and there's ways to get around that. You can do a couple things. You can have your heat pump and have a wood stove as a backup. Or you can have a heat pump by itself or a heat pump furnace combo and use a generator backup. So a lot of homes here have the generator. You plug in the outside of the house and it's great and it operates, and if we have a 1 to 2 week power outage, if something happens, you can do that. We give them that stuff on file. We give that information to the homeowner as a tip. So they feel more comfortable knowing that the decision they make for what type of mechanical system they want to put in their home is their decision, and there's many ways to do it. So it depends on what their system is. Let's say they're snowbirds. They're not here in the wintertime. They're not going to be around to see what happens. A wood stove wouldn't make sense for them as a backup source. Who would heat it? So they would go to, let's say, a heat pump or a furnace, and they would have a backup generator, or they would have someone stay in the home at the same time and just keep an eye on things. But if you are home all the time, a wood stove, if you're out a little bit outside of town, you like the wood heat, you give them that option. So the important thing is to make sure that your furnace or your heat pump or any mechanical device you're using is efficient, and make sure that it's operating at the correct standards of today so that you're not overspending on consumption. And not to mention just your mechanical system, we look at the priority sequence in which you need to do things to your home. So we always say air leakages first. If your home is drafty, it's just like being in a canoe. If you have a beautiful canoe, you got holes in it, it's leaking water, I don't care how nice and fiberglass quality canoe you have, it's just not going to work. But you need to focus on air leakage and insulation first. Make it tight, make it insulated well, and then consider your furnace or your heat pump.
Open Connection will be right back after these messages. And now, from the CFTK-TV studios, this is Open Connection with your host, Robert Pictou.
Once the energy advisor arrives, they'll confirm your eligibility and then run a series of tests. Following the evaluation, you'll get a homeowner information sheet and an EnerGuide label with the current energy efficiency rating of your home. You'll also get a renovation upgrade report, so you can see which retrofits will improve your home's energy efficiency and resilience. Armed with this new information, you can be confident that your retrofits will make a difference.
Since air outside will always contain some heat, a heat pump can supply heat to the house even on cold winter days. In fact, air at minus 18 degrees Celsius contains about 85% of the heat it contained at plus 21 degrees Celsius. In this final segment of Open Connection, Certified Energy Advisor Nick Gascon tells us more about heat pumps.
So there's a cold climate air source heat pump that's very common in the Northwest BC. It does work in our climates. It does work up to minus 20. People will speculate back and forth on this, so I try not to get too big on it. But so in this situation, a heat pump works with thermal energy. Essentially, there's a fluid inside that either expands or condenses. It gets really hot and really cold, and there's fans on one side and the other. And the way it works is, if you want hot air in your house, you just turn the fan on that lets the hot air in. If you want the cold air, you just turn the fan that turns the cold air on. And that's the easiest way to identify a heat pump. With heat pumps as well, there's another piece of equipment that's very important to know about, which is an HRV. And HRVs are designed to work with any sort of mechanical system, and it provides fresh air into the home and takes out the stale air. However, a heat pump or an HRV works as a heat recovery ventilator, and it recovers heat. So as any system works, it needs this balance of air. And when the heat that you just created in your home needs to leave in order for fresh air to come in. But that heat, when it goes to leave, heats up almost a radiator inside this heat pump, this HRV, and the fresh air coming into the house will warm up from this radiator, so you get pre-warmed air from the heat that you already had. So it's about 60 to 70% heat savings just from recovering that heat and keeping it in the home, but still removing the stale air. So back in the 60s, a lot of homes were designed to be a bit on the drafty side. And that's just the way it was. We need a little bit draftier, turn the wood stove on in the winter, really keep that house really nice and hot and dry, and it's just how we did things. And today we're realizing that we're using a lot more gas and a lot more electricity today, and we're losing a lot of heat through these leakage points. So they're creating homes better and more airtight, and because they're airtight, we have to focus on things like humidity and making sure we don't have any issues in the home. So they're taking these HRVs, these heat pumps, and these balanced mechanical systems to control the air coming in so that it's clean and comfortable and everything is perfect in the home. And they're removing that stale air while controlling the environment. And by doing this, it's been an incredible reduction in the amount of energy consumed. So today's technology, there's triple pane windows, and they have the low E argon in them, most of them do. And these windows go from, say, an R1.7, so the higher the R value, the better. So R1 or 2 is what the windows can be in these older windows. Can go up to an R3.6, R2.7, somewhere in there, right around that R3 range, right? So you're tripling the insulation in a window by getting a higher quality window. And not just the window panes itself, there's also things like low E coatings, where you might have beautiful big windows that are facing south on a house. But in the summertime, it gets really hot. It feels like a greenhouse. So you can do things like get a low E coated window, which is like a sunscreen that allows the sun to come in, the light, but not the heat. So you get that little bit more cooling effect, and your house isn't trying to cool your home as quickly as possible with all this heat draw. You can do things like add mirror coatings to them. You can do different tricks, but the advisor will look at a home and really assess it and go, this is where we recommend you do a couple things, and those little tiny details are what you get from that tangible visit from an energy advisor. Especially in the new construction world, where your north windows should be smaller and thicker, triple pane, where your south side windows, you can afford to have bigger windows because they're going to draw in the wintertime. That's where most of our consumption is, the winter here. So you could have those south facing windows big, allow a little bit more light in, and they can do it, right? So, but the bigger the window, the less R value is. So a typical wall is R19 or R22 in R value, versus a window would be R2. So if your window is bigger, you're losing that R value from that insulation in the regular wall cavities. So you have to think about how much window space you want versus how well you want your consumption in your home.
Thank you for joining us for this episode of Open Connection. The greatest distance in the existence of man is not from here to there, but the connection from his mind to his heart. If we can conquer that distance, we can soar like an eagle and realize our immensity within. I'm Robert Pictou.